everyone. Yeah, this is the not the first time, sorry, the third time I'm here in ReactNext. And we're going to talk about, yes, we talk about how we're doing wrongly and why you're not working. Yes, we are. And of course, everything about my presentation is doing wrong right now. I hope along the way it will do better, but you got it. So before that, I'm Maya Shavin, and I'm senior software engineer for Microsoft, and I'm also a GDE, which is Google Developer Expert. Don't ask me why. It's kind of Microsoft and Google together. I don't know how that happens. Yes, I'm also have a book coming up on Vue. Yep, I'm also working on Vue and React, and here I'm not talking about why this one doesn't work. I have to point like this. And this is not a hate talk. Nope. I'm not here to talk to you about how I hate React. No, I'm not. I'm not hating React in general. And I'm not talking to you about the new framework, whatever's so great about other framework and why React is slow or something else like that. Well, I'm going to talk to you about a very opinionated talk that tell you about my personal experience and what I learned over the years when working with React and React hooks. And before that, 10 years. React, it's been 10 years last week. So, yep, congratulations again. Happy birthday to React. We've been there. We've done that 10 years. Yeah, we've been the 10 years of big milestone for a library. Well, apart from jQuery, you're getting close. It's still not there yet. And we've been through a lot of, a lot of release, a lot of breaking changes, a lot of pain, tear, happiness, especially like 16.8, we have functional component. I call this one is when you start to be a teenager for React. And then you got to 18 plus. Oh, now you're an adult. You can use server components one step closer to being a BSP for the client side. Anyway, 10 years. You probably thought that 10 years with React, we probably have everything is stable. Documentation is stable. Every best practice out there, everyone know how to use the framework correctly, right? Unfortunately, they just come out with a new documentation site. Finally, 3 months ago, they considered the full documentation site that work properly, consider everything there is the right way to use React and React Hook from the beginning. And I'm so happy. I waited for so long for something to help me to start with React Hook. But before that, and even after the documentation site will come out, I'm still seeing this. Why this one is working weird? Okay. I'm still seeing a lot of things like useCallback, and again, more useCallback. The clicker doesn't work. Anyway, yep, and use effects, not use effect everywhere. And we have tons of videos, tons of live, of blog posts, tons of talks talking about how we shouldn't use callback, right? Sorry, not use callback, use effect. I need my coffee. Yep, I need my coffee. And yet, we still didn't get there. If you look at this blog post, this is actually a real documentation. It's still there on a Zoo static web app telling you how to use React, use effect React example. And this code staying right there. If you just copy this code and put in your application, what will happen? Your application probably stuck forever because it's rendered forever. And this happened also on the old React official documentation. If they do it wrongly like this, how do they expect us to do it right? Well, but today I'm not talking about use effect. That will be for the later talk today at 5, I think. Today I'm talking to you about a different way, different things that bother me the most is how you use for callback and useMemo, and we actually use too many things. We use React hooks everywhere. And one of the things is make me feel very bad about this. This actually is actual code in productions. Except for the white one, it's not our code, it's not our code base. It's from the component library, done by Microsoft. And they actually use callback for on change on an input element. And why would it be bad or good? We talk later on. Either way, when I use React recently, I feel like I'm the fish on the hook with all these use callback. And every time when I open, like this. Okay. And, okay. Ready? Okay. Yeah, now you don't hear me breathing. I feel very weird when people hear me breathing, which means I'm very scared right now. Anyway, so I feel every time when I open a PR that assigned to me and I have to review, I'm very, very afraid because I feel like I'm really hooked with React. And if this is what React team meant when they named the words React hook, they got me. And the reason why I feel like fish on the hooks is that every day when I try to ask my college, everyone in my team, why are we using so many React hooks in our code? They told me this. It's always good to memorize for performance. Come on, it's a myth, is it? Well, of course, you say that performance optimization is including memorization, and because you memorize it, you don't have to re-render and so on and so forth. Is it? Let's take a look at, come on. Okay, useMemo. So we have useMemo hook, and it is a hook that meant everyone, you hear useMemo hook, right? Anyone that not useMemo hook, raise your hand, please. Oh, come on. You lying. Anyway, so this is a very common hook to catch the result of calculation. Just remember, it's catch the calculation. And you can use it by adding, wrapping the whole functions and inside the useMemo. Make sure your function always returns a certain value, otherwise it wouldn't work. What it does, what it means for, is for skipping the expensive calculation. Emphasize expensive. The second thing is it's used for skipping re-rendering for components. And lastly, have anyone ever seen it run twice in your application during development mode? That's bugged me a lot because it runs twice. And according to the documentation, it's supposed to run twice because if you don't do anything wrong, whenever it runs twice, it doesn't do anything. I'm not sure I understand the concept, the concept behind, the reason behind this explanation, but okay, it runs twice, just to make sure that if you do it right in the first place, you will do it right the second time. Okay, but that's not the point. The main point here is how much is considered expensive? Anyone give me an answer? Is it 10 shekel is expensive? 500 shekel is expensive? Or half a shekel is expensive? Well, let's take a look at our demo, okay? In this demo, I'm going to render a list of items, 100 items. And, of course, I'm using, not VTest, but I'm using Byte here. Anyway, so this, behind the scene, I'm going to, of course, get the list of items, static. And I'm going to have a component called list item. And, of course, I have to do. Oh, it doesn't work. I have to do, so I need to implement the to do items. I have one favorite, I have local state favorite, and so on. So what I'm going to do now is I'm going to run. Oh, you know what? I'm standing right here. Okay. Yep. And I'm going to run a test with 6 clicks. 1, 1, 1, 1, 1, 1. Just very simple. 3 click to enable favorite, 3 click to disable favorite. And without useMemo, and with useMemo, you can see the code is almost identical. Of course, the useMemo, you have to add at least 2 upper line. And the useMemo, I add the favorite item as dependency, so it will re-render if the favorite item change. Nothing really complex here, right? Now, come the next question. I'd like to ask quiz and question here. Which one can tell me, which between these two, is the profiling result for useMemo? The below, but the top or the below? Oh, come on. Why everyone answer wrongly? The below one. Yes, you're right. It's the below one. Oh, you're probably good at it. You don't need to be in my talk. But anyway, yeah. Yes, the below one. And as you can see, the change between the bottom and the below one is like 0.2 to 0.5 millisecond. Not a lot, right? So I decided to do another test on thousands of items. Again, which one of these is for useMemo? Who said the top? Who said the bottom? And the rest that doesn't raise your hand, I mean, you don't know or you don't care or... Anyway, yes, the one who said below is the correct one. Unfortunately, I don't have any unicorn to give you, but yeah, you're right. You're good. And as you can see, the change is also very little. And pay attention here. There's something I want to you to pay attention very closely because I'm going to ask in the next slide. And what does that mean? Of course, 1,000 objects, according to React documentation, is not expensive enough. So they say that unless you have more than 1,000 objects, you don't probably don't need like memorization because it's not expensive. Probably. They're not saying that it will not be expensive. It just say probably not expensive. But again, here come the things. Since when whoever still doing the front end that render 1,000 objects on the client side? Is any one of you ever render a list of items or data from the server side to the client is larger than 100? Raise your hand. Oh, wow. How about 200, 300, 1,000? You still? Wow, okay. You probably need useMemo. Otherwise, I mean, if not, then you probably use like paginations, virtual scrolling, because we don't want to render that many items. You know what? We scroll up to 1,000 items on the client side. In any case, and so let's do another talk, another calculation and test. So this is the official recommended way of measure how expensive your code is. So you're using console.time and console.time ends to wrap up on top and bottom and run it to check what is the log time. And I do run it, and they say it, according to the documentation again, they say, if the overall log time is more than 1 millisecond, then you may make sense to use memorization. Again, might make sense. I will like, either you make sense or you don't make sense. What do you mean by might make sense? You mean you're not sure? You are the React team. What do you mean by you might make sense? It doesn't make sense to me. So anyway, because of this, I do another test. And this is the result of two tests. One with the memo and one with useMemo using the time log. Okay. Now here come the questions. What do you see here that is troublesome? You're right. Good. Well, it's hard to miss though. Come on. Yeah, the first render, you can see that the first render, the significant difference between the useMemo and the useMemo is huge. It's more than 10 milliseconds. And so when you use memo, you actually doesn't gain any fast re-render. Meanwhile, the re-render thing is very little. It's not even reached to 1 millisecond, and this is for 1,000 items. So here come the questions. What does it do underneath that cause this very long first render? What you may know already is first, define the dependency. It triggers the function to get the calculations, and then it allocate the memory to cache the value received from the function trigger. And then on the second re-render, it will just, come on. I feel bad about this. When the first next render, you will see it will repeat this one again. So now my question is, where's the garbage collector? Where's all the cache value? Where does it go? What does React do with it? Does it collect it or does it where does it throw it? I couldn't find a single answer in the documentation. I have no idea. But this is what caused the slow first rendering. Because it really depends on how the function trigger, how slow it is, and then how long it's getting to catch. And every time you need to catch again, you need to trigger again. It can slow down your application significantly. And do you really need useMemo on this? Well, you answered yourself. Now here comes the next one. Oh, this is my favorite, useCallback. Because this is useMemo. I don't really argue with my colleagues a lot, but this is like every day I was arguing about it. Why do we want to use useCallback? So what exactly is useCallback? So useCallback is a React hook that what it does is catch the function definitions. It's similar to useMemo, but it's catch the function definition, and you can just wrap the whole function in useCallback as a dependency, and it will trigger whenever the dependencies change. What it does, it doesn't do like to help you skip on the expensive calculation, but it doesn't do any calculation. But it keeps re-rendering and optimize the custom hook. The second line is very funny. I mean, funny for me. When I look at the documentation and they say it's used for optimize as custom hook, I was like, what kind of optimization are you doing here exactly? What kind of custom hook do you need to optimize with useCallback? I mean, if you have a reason for it, you can tell me after the talk because I still haven't found the reason why they write this code. And the code example doesn't really give me any real explanation for this. Anyway, but it does give me one thing. The useCallback doesn't prevent creating functions. That's nice. It doesn't prevent the creating function. So whenever I re-render, it creates a new function definition anyway. But React ignore it, and then it steals the cache version for your sake. And it doesn't care about the function that created. Sounds good, right? But I think it sounds a bit weird here, because why do I wanted to ignore things and didn't prevent the creation? Didn't I supposed to prevent the creation so I don't have to ignore it? Well, let's take a look on the first rendering of useCallback then. Similar to useMemo, in the first render, they define the dependency, and then they allocate the memories to each of the function definition, and then you get the cache version of it in the memories, and then every time when it's triggered, you will get a new cache version. Okay? And then when the function trigger, it will take the latest version of the cache function and trigger and run on the function on this cache version, like on the dependency already cached before, on the dependency value. Now, another question is, where is the garbage collector here? And does it really help you in any case here? Well, let's take a look. Which garbage collector? Very simple, straightforward, just a function. We're not talking about whether arrow function is good enough in this case. Just assume that it's good like the normal function. In the normal JavaScript mechanism, you got the garbage collector immediately. So if React ignored, the function definition was created. If it's not in you, it will be flush afterwards. So you don't really need to do anything with it because this is the default mechanism of JavaScript. However, when you use callback, you have zero garbage collector, which means it will still keep a whole stack of catch version of your functions, and then it choose the most latest one to trigger. And the other one, it just leave it there. I got no what for what. It just leave it there in the memory. And if you have to trigger the re-render and catch in on this function again, you will end up a lot of version of your function inside the memory. And that comes to the next question. How many times this function will be invalidated, or in other way, in render again. Catch again. Anyone can answer? I take silence meaning you know the answer, or you don't bother to answer me. No, it's joking. Anyway, well, of course, because you saw the dependency, so it really depends on how frequent the favorite items here change, right? But the problem here is I set the value of favorite item inside the functions, and it's the on-click event. So every time when you click this function trigger, it will set the favorite, and then the favorite item change, and then it will create another version of cache for this function. And that means there's no point to use callback here. You will end up with a lot of version of on favorite in your memory, and then it will at some point it will slow down your application, and that's bad. And this is actual issues that were open in 2018, and it's still open until now, until today. They discuss about a lot of workaround, and then some workaround doesn't work with concurrent mode. It doesn't solve the problem. It's still open there. Oh. And that's the point where I saw this, and I'm like, oh my God. So why? Why do I use it? Of course, some people would say you can actually overcome this problem by just pass the set of functions to the set favorite, which is the local set state, and then leave the dependencies empty, and this will be catched once, and only once. And it solves the problem because there's no dependency. It will not re-trigger the re-catching for this function. Great, right? Now here is called my small quiz. What is the output value for count in this function in every increment click at the line of console log count? Who say 1? Who say 3? Who says 0? It's 0. So if you're using this, you actually put your function stale, with the value of the count. Which means if you ever write something that need to access the count variable inside this function, you doom. It will always use the first render value of the up count, and it will not take the latest value, and you have a very mismatch. And this actually, this actually come from a very, very true story for myself. We have a bug. I was developing a very complex component, and along the way, somewhere I figure out that the top, I pass the callback to the bottom functions, and somehow I keep getting the error that the top functions, it doesn't get the latest value. Of course, every function passing, you use callback. And then after I investigated, I found out that in the middle, there was one function was wrapped inside useCallback, but it was dependent on another value that is not related to the one I'm listening to. But inside this function, it using the value that I'm listening to. And that happened that from this moment, from this function that using the wrong dependency, now everything works. The value is updated correctly, and you can access the updated value. From this moment up on the top, I cannot get the latest value because my function is catched with the previous value of the things I wanted to get. And that is horrible. It's very hard to fix it. And that's come to another thing. When to use callback? Well, according to the documentation, I'm going with the documentation. You only use callback as the function to a prop of a memorized component. A memorized component, not any component. A memorized component using react.memo. Okay? And the second thing is, if your function is used later, a dependency is another hook, which here, they didn't say, but which here, most likely you're using use effect. Other than that, I don't see why you will care about this, but they don't explain further on this again. And I would like to add another line here. Because when you don't care, this is not from documentation. The line here is me. Because this is come from the fact that I'm talking to all my friends in college and they're like, yeah, it doesn't do anything. You put it there. Well, it may help you memorize and optimize the performance somewhere in the future, but it will not do anything much. And you don't care. But of course, you're wrong. And again, you may not need memorization. Why? Because you see, the memorizations you do is very little, like 0.2 milliseconds, and the trade-off is much harder. It's trade-off about performance in the long term and so on. And also, let's look at the re-render cycle flow. In this case, I have a parents which control the state of a modal, and the modal will be open when the parents click on the set on modal. Okay? But according to the re-render rules, you can see here, that is waterfall re-render. When the parent change re-render, everyone re-render. It doesn't matter. But here, I specifically don't want the parent to re-render. Because why I want the parent to re-render? I just want the modal to open. And then, if I pass the set in modal to open modal, and I click here the callback, the whole thing re-render again, because now the open modal is the parent's local state. And once the local state changes, the whole component re-render. And this is not good. And this, no matter how much memorization you're doing, how much useCallbacks you're using, how much useMemo you're using, this is unavoidable and it will be problematic for you. And that's what we call live-up state. So what we can do, instead of using memorization, we shouldn't live-up state. No matter what state management library you're using, even if the fastest state management, if you ever live-up state or put it wrongly in your code, you will end up suffer from performance. And again, React is not slow. Redux is not slow. You are slow. I'm just to make it. Anyway, the second thing, you need to minimize the dependency list. If you ever use it, try to minimize it. Rules of thumb. If you have more than 3 dependencies in any of the hook, you probably do it wrong. Because when you have more than 3, you cannot control what you're going to use. Like, for example, in this case, each arrow and each tag is still okay, right? But why? Why each arrow? Because the task always change. The task will change when each arrow is true. And then if you add another is loading, and then you define the task value according to each arrow is loading and the task, it doesn't make any sense. You don't need that here. And then you have another useMemo, another useMemo down there for what? So plan and validate your code design. And lastly, don't use callback for internal or lowest level function. What does it mean? Don't do like this. You don't need this one because input is not a React component. It's a HTML tag element, and it doesn't care what useCallback you pass to it. It will always re-render. So you are memorize something that's not need for memorization, and that is not good. And lastly, like I say, everyone have a trade-off. Everything have a trade-off. And whenever you think of performance optimization, it's not just about optimization. It's just about what the trade-off you're doing for that optimization. Something else may trouble you in the long term in exchange for it, and you may not need it. Because memorization is also not free. The free stuff is probably not real, unless it's for sales. But anyway, that's my talk, and thank you very much.